All right, so in this example, we're going to extend lesson 5, things we learned in lesson 5 and prior, and we're going to do an extended demo to hopefully give you some context for what you've been learning. So we're going to use the insert cursors, and we're going to use some other packages, and we're going to take a CSV file and essentially make it spatial. So we're going to do our imports first, and we're going to import our OS argpies, and then we're going to import a package that we haven't seen before. And this is Pandas, and Pandas is an important package, and you'll become more and more familiar with it as the course goes on. And it's going to allow us to do a lot of data manipulation and data science stuff. And it's also integrated into the ArcGIS API for Python very heavily. So we're going to import Pandas as PD. And this is, you can recall from previous courses and classes that this is a way that we import pandas and set the name that we want to refer to the package, because I don't want to have to retype pandas over and over again. I want to shorten that to PD because I'm a lazy programmer. Now I'm going to go ahead and take advantage of one of Pandas' most intriguing things, and that's the ability to pull down information easily from various sources. So I have a CSV file I'm going to pull from somebody's, this user right here, that has a monuments.csv file on there. I'm going to use the head, and what head's going to allow me to do is look at the first 5 rows. And you can see it gives us a snapshot of our data and what we have here. So we have nom, which is name, xy, which is probably Web Mercator, but we're not 100% sure. And then we have something that's very familiar with most geographers, and that's lat long. And we're going to use lat long and nom, and we're going to associate that and create our feature class using that. So let's create our feature class first, and here we're going to ensure that we only want one copy of it. So I'm going to check if it exists. If it does, delete it. The other thing I could do here is I could say check if it exists. If it does, use the argpy.create name, create unique name, and pass it in. But I don't want multiple instances that could possibly exist, so I want to explicitly delete it. So we're using our if logic here. So if it's true, then we run this delete. We're going to create our spatial reference and then generate a blank feature class. So here we have our point, our point feature class that's within our file geodatabase. Now we can go ahead and we can add the associated fields with it. So in this case, what I'm going to do is I'm going to add 3 fields. I'm going to add lat long and nom, which is our name, and then we get a list of all our geometries. I'm then going to go ahead and I'm going to list out my fields to explicitly get the full list and put it out, and see that now I'm ready to pass that into my cursor object. So we can go ahead and we can look at our data and how we can use this. So here we have our dictionary, and I'm going to sort of take my data, massage it, and only get one row, and I'm going to convert it in to give it a sample of how our data feels. So here's our key value pair representation of our data. It's not spatial yet. So now we're going to go ahead and we're going to use our cursor. So we're going to use that with pattern that we've been seeing because we want it to automatically close our cursor when we're done, so we don't want to keep that lock on it. And then we're going to go over each row within our data frame by using df.values, and we're going to insert a new row. And then finally, we're going to clean up and release the locks when we leave our with statement. And then we're going to do an additional delete to make sure it really does get removed. But in reality, this is not needed. So here here we see the code we just explained. So within that for statement, what we're going to do is we're going to create our point, and then our point geometry, and then put it in. So we know our field names look like this. So we need to get the name lat and long, and then the point geometry. So let's go ahead and create the feature class and add that in. And let's see how many we got. So we have 48 monuments. Now, I'm just going to use some basic functionality of the ArcGIS API for Python within the Jupyter environment. And we'll cover this more later in the class. So We have WGS 1980, our coordinate systems with the monuments. We're going to go ahead and add them to the map. We're going to zoom. And then we're going to add this information to our map. Convert it, make it spatially enabled, and add it to the map. And let's see where it takes us. And there's our points in Montreal. So all 48 points, we had the monuments that existed within Montreal, and that explains why Nam was in French and not in, it wasn't named. So what we were able to do very easily, using a combination of both the ArcGIS API for Python and spatially enabled data frame, which is part of the, and the spatially enabled data frame plus ArcPy, we're able to create a persistent data set in a file geodatabase, push that back into memory, and then display it in a map, all with a few lines of code. So you can start seeing the power of taking all these geospatial tools and chaining them together to provide and get some meaningful information back, whether it's rich representations like this or in earlier examples where we were creating graphics. All right, so this ends the lesson. If you have any questions, please post them in the lesson 5 Blackboard discussion. Thank you.